Hi, welcome to CSE114 Introduction to Object-Oriented Programming, and in this lecture we will discuss exception handling, which is a very important feature of Java programming. So let's see what we will discuss in this lecture. So whenever we write a program, then it is possible that we may have some error in the program. So far the errors that we look at were compile time errors. That means those errors are the ones that compiler can easily spot, and compiler will give us an error message that there's something wrong with the syntax. So the problems like missing semicolon or not using if-else statement properly, like something wrong with the syntax. So that kind of errors that you have in the program are called compile time errors, which are mostly notified by the compiler. Compiler will tell us that there is some problem in a specific line number, and will also give some hint about what is wrong, like probably we are missing a semicolon, or probably we are not using a statement properly. In this lecture, we will look at something called as runtime error. So that means when you're running your program, then you see something missing. So the problem is not with the syntax of the program, but the problem is probably with the kind of computation that we want to do. So these kind of errors are called runtime errors, and we have these exceptions. The exception handling feature of Java, which helps us in solving most of those issues. Okay, so when a program runs into a runtime error, then the program usually terminates abnormally. So you might have seen that already. So I'll do a demo before I advance to the next few slides. I have planned to do some demo and give you some idea about what these runtime errors are and how do we want to address these. Right, so we have to learn this technique where we have the complete control of our program. So we want to handle these runtime errors. So these runtime errors may happen. So as an example, one of the example that we can have of a runtime error would be if we are doing some division of x by y. So when you are dividing x by y, then y should not be a 0. If you divide something by 0, then that is not allowed, right? So that is an exception condition, and we should know how to handle these situations. If not, then our program will terminate, but will not terminate in the way we want. It will terminate abnormally. So what does that mean? For that thing, let me take you to some demo programs. So what I will do, let me write a very simple program for you which deals with the divide by 0 kind of situation. So here I have already written some lines of code. Here I'm taking the input from the user. For that reason I'll need the scanner class, and therefore I created a scanner object right here, named that as stdin, and then have declared couple of integers num and deno. So num means numerator, and deno means denominator for this program, and I am accepting these inputs from the user. So let me close this stdin dot close. Alright, so let's do let me add 2 more lines, and here this should be the result of division is. Now we can perform this division operation, which would be numerator divided by denominator. We know how to do the division of these two things. So let's run this program. Well, let's give some value like 10 and 5. Numerator is 10, denominator is 5. So the result is number 2 as expected. I may make that capital letter. And this integer division, if I say 10 divided by 3, you'll get 3 as the answer, because It's integer division, so you don't see anything after the decimal, no decimal point here. Now let's try to do something interesting where I will pass on the denominator as 0. Okay, so let's see what will happen. Now you can see what happened. The program terminated, right? And why did the program terminate? Because we are doing an operation which is not defined. Divide by 0 is not defined, right? So what happened? An exception was raised. So if you try to understand the output that we are receiving as the result of this program, then the output in itself is saying that in the main method we had an exception. The exception type was arithmetic exception. So what is happening in this current program? Exception has been raised, but we did not raise it. JVM did it, right? So what do we want to do? We want to control it ourselves. I should write my program in such a way that my program has the capability of identifying these situations like this arithmetic exception and taking appropriate action, which is missing in my program. So I'll do a very simple demo, and I'll give you this idea like how can we add this exception facility in this program. Okay, good. So what should be done? Well, let's try exception, and then I'll tell you a few other interesting things. So how do we handle this kind of situation? So Java has this feature of try and catch. We will learn about try and catch in detail today, but these are the blocks which helps in writing the exception. So I'll have to use try and catch to handle this situation. So what do we do in the try block? These try and catch go together. In the try block that you see between my opening and closing curly braces, I will write the statement where I have the possibility of an exception. Okay, so only here I can have an exception. Exception means a situation which is not normal, right? Dividing by 0 is not a normal situation, and so it is not allowed. So in case there is any issue, in case there's a situation where the user has given the value of denominator as 0, then we need to address that. Okay, so the point is, if you look at whole of this program, and if you look at these individual statements like the statement in number 4 till statement number 9, then everything is perfectly fine. Okay, I'll assume that the things are fine, although we can have some situation in line number 7 and line number 9, which I'll handle in my next example. Assuming that when we are saying that the user has to input an integer, they will input an integer. Okay, so alright, now the only problem that we can have in this example is when the denominator is 0, and right here we are doing the numerator divided by the denominator computation. So this is the code that I have in the line number 11 is the one where I can have an exception. So the lines where I can have exceptions, I should put that in the try block, and try is followed by a catch block, and the catch block is written like this. You will have to pass on an argument to the catch block, which is an exception object. So exception is a class. We will learn about exception in the next few slides. So after the try block, you should write a catch block, and the catch block takes an argument which should be of which should be an object of exception class or subclass of exception. So here I'm using exception. So ex, which you have as an argument for catch, its type is exception class. And now what we can do here we can write the statement that we want to have in the catch block. We'll say that denominator is 0. Okay, so this kind of exception can happen, and when that is happening, then the try block will detect the exception, and the catch block will take the appropriate action. So let's see what happened after adding these line of code from line number 10 to line number 15. Let's see what changed in our program. Numerator 10, denominator 3. No problem, it is working just the way it was without try and catch. So in case there's no exception, the life would be as normal. Okay, and if we have an exception, so let me give some inputs like this: 1 divided by 0. So if you remember in the earlier version where I did not use try and catch, the exception was being raised and Java was handling that. But now I have written my try and catch block, so see what will happen. Okay, so you don't see any red fonts and all looks quite normal. So what has happened now, because I have written the try and catch block, so I have the full control of my program. I put the statement where I can have the exception in the try block, and I have written a catch block, corresponding catch block for this try statement. And if there is an exception in the try block, then the corresponding catch block will handle the exception. Alright, and how did I handle the exception? By writing a statement in the catch block which says that your denominator was 0. Right, so this is not good. Great. Fine, so I've just given you a very simple example of how we can use exception handling using try and catch block in Java. Now you might argue, and the students, they do argue, right? So, and not only students, any person who's learning try and catch for the first time, they will argue that there's nothing great about it. You just want to check the condition that whether the denominator is 0 or not. If the denominator is 0, then you can anyway, if the denominator is 0, then you should not attempt to divide, right? So that the thing is that we can also handle this very simple scenario with the help of if and else statement, which is perfectly alright. But we can use if and else statement in this simple code. But as the things get a little complicated, then if and else statements may not have the power to handle with the more complex exceptions. Okay, so let me do the demo in that direction only and introduce if and else. So you may say that let's not have try and catch at all, and in place of try and catch, let's use if and else. So how can we do that? I'll say if denominator DENO is not equal to 0, then only we should do this division. Otherwise, what should we do? Otherwise, we should do something like this. Perfectly alright. Why? Because this is such a simple example that you can handle this case without exceptions. So let's run that. If you have 10 and 5, answer is 2. Good, great. Now let's try to divide by 0. 2 divided by 0. So denominator is 0. Fine. This was a very simple case, so you could handle that with an if-else statement also. Now let me make it slightly complicated. The problem remains the same, but I'm changing it slightly just to give you an idea that if we make it slightly complex, right, then this if-else statement may not work the way we want it to work. So how will I change this program? Let me write a method for this. So this method will do the division. So I'll say public static int get quotient. Alright, and it will accept x into y. So it will do something like this: return x divided by y. Alright, so I haven't done anything great. What I instead did was, rather than computing x by y, which is numerator by denominator right here, I am simply doing this. I will call this method which is get Let me copy this guy from here. Okay, and numerator, denominator. I don't need even else, so I take it off. So what did I do? Just to motivate you, just to give you some idea that um, if else statement will not work in all the cases, what I have done, I created this slightly, I changed the program slightly by creating a method called get quotient, right? And let's see how whether this is working or not. Numerator 10 and denominator is 4. Good, right? Fine. As long as you don't have any exception, as long as you don't have divide by 0, it's working perfectly fine for us. What should I do now? Let me say 3 divided by 0. Well, yeah, we got the exception, but now this exception is again raised by Java. We haven't done anything. We want to control that. We want to handle it ourselves. This is our program. It's our responsibility to take care of exceptions as well. If we are leaving everything to the Java, then that's not a good thing, right? At least exception is something we need to learn so that we can handle it. Good. So what do we do? Let me write one more statement right here. Done with the program. Have a great day. So this is a greeting that I am writing for my in my program, so that if everything goes fine, then the line number 12 should be printed out, which would just print a greeting that says that I'm done with my program and you have a great day. So let's run this, and when you're doing 12 divided by 3, then you see the result, and you also see the greeting which says that you are done, I'm done with my program and have a great day. And in case I give a value which has divided by 0, 2 divided by 0, you don't see anything, right? What you see is no result, nothing. What you see is just this exception message which we are getting from Java, because we did not take the responsibility of handling exception. So let's look at this situation, like how can we solve this problem. So what we can do here, we can make use of if statement, right? So let's see whether if can help us or not, and if we are able to use the if else statement for exception handling, then what can it do? So I can write if statement that says that if y is equal to 0, that means your denominator is 0, then what should we do? System dot exit. Alright, 1. What does it mean? Well, things are different now, right? How is the thing different than the program which we wrote with if else statement? Well, in that case, the whole program that I had was written in the main program itself, but now this is slightly complex. The exception that we may have is happening in get quotient method. It's a different method, right? Its exception will not happen here in the main program, but exception will happen right here. Okay, it will happen on the line number 18. And when will that happen? It will happen when the value of y is 0. So what we did, we are saying, okay, fine, if the value is 0, then let's not do x by y. Instead, what we will do, we will exit the program. That means we will kill the program. Alright, so let's see how is that helping. Okay, let's put 12 and 5. No division by 0, so perfectly fine. More complex example, 3 divided by 0. What happened? Well, the program is not running. Program did terminate, but the program did not terminate gracefully, right? So we did terminate the program right here on the line number 17. The program did terminate because of system.exit statement, but the program was able to terminating in a method get quotient, right? So this is not considered a good programming practice where you terminated the program in the called method. Ideally, what should happen? Ideally, when you see this exception, you should be able to return back to the method. You should be able to return back to the main method, and then even after exception, you should have said this thing like, we are done with the program and have a great day. So see, we don't have any statement printed in the main method after the call to this get quotient method, right? So although if statement is helping us in some way, but if statement is not helping us in handling this exception gracefully, right? What does that graceful thing means? That means I want that this issue that we are doing divide by 0 should be reported back to the method which is calling get quotient. It should be reported back to the main method by the get quotient method, and then the main method will decide, like, okay, if there was an exception handle exception situation, then how should we sort that out. Okay, so what I will do now, I will modify this program in such a way that it is raising an exception, right? It's not handling the situation by exiting it. So how can we modify this? We'll have to change the definition of this get quotient method in such a way that we convey the fact that this get quotient method has the power or the ability to handle exceptions. Right now, get quotient doesn't have that exception handling capability. So whatever I will be doing here, we will have a systematic discussion of that through my lecture slides. But since I'm doing a demo here, and the purpose of the demo is to motivate yourself to exception handling. Okay, so what should I do here? I will say this method throws. Alright, so you will have to be more specific about this method, and you'll say that this method will throw, it throws what? Exception. Alright, so you will have to modify its header, and you'll have to convey the fact that this method has the capability of throwing exception. It is more what I should say, it's more refined, it's more sophisticated method. It will throw exception, right? So you will say throws exception. And then whenever you see the situation where y is equal to x, what we do instead is that we create an exception and throw that. So how is that done? We'll say throw. We use the keyword throw to throw the exception. Throw new exception and here you will write the statement division by 0. If y is equal to 0, then throw new exception, new this way, right? Not capital, simple. The keyword new is in lowercase letter. Alright, so what did we do? We modified this method a little bit by adding this declaration which says throws exception, and then whenever y is equal to 0, we will create an exception by using new exception, and this constructor that you have for exception class will accept some string, and in the string that we have, we are writing this message that this is division by 0. If you want, you can say exception, which is division by 0. Alright, so as goes get quotient is prepared, right? So we have written a method which can handle exception. Now we need to do something here also. Now the line number 10 that you have, which is continued to line number 11, because this is a bigger, this statement is kind of longer. So what we have to do, we will put that in the try block. Why? Because the exception can happen here. So this guy goes into the try, and then we will write a catch. Catch will have exception ex. Alright, and what do you do here? You will say ex dot get message. Right, so there is a get message method in the exception object, so we are just using that. So now let's run this program. Okay, so when you say 5 divided by 2, perfectly fine. And then let's do an exception situation. I say 3 divided by 0. Alright, so see what happened. This is a graceful handling of exception. So how can I say that this is graceful? Because look at the point where this program is completing. So the program is completing on line number 17 in fact, but you can see the statement which is a println statement on line number 16, that is working, right? So we are getting this message which says that we are done with the program. Okay, but we are not very happy with the input, so we are conveying that in the exception message. It says that the division was attempted by 0, so you don't have the result of the division. Instead, we are saying that yes, there was an exception, we handle it, and the exception was because of division by 0. Okay, so this is what we mean by graceful handling of the exception. Okay, so how did we do that? By using try and catch block. Alright, and we did write a method for this case just to give the just to illustrate the power of exception handling over if statement for a very simple case. And for that purpose we had to modify the get quotient method as well. Alright, so now I'll take you to the lecture slides. Let me use my pen here. Okay, good. So whenever our program runs into runtime error, example being where you have a situation like x by y where y is a 0, right? So that will be an example of runtime error, and then the program will terminate abnormally if you don't have exception handling in your program. What we want to handle these runtime errors or exceptions. Alright, so we want to be able to handle the runtime errors so that the program can continue to run. Right, the program that we wrote, that I just showed you in my demo where we modified the get quotient method, it is helping us to continue the running of the program. Even after the exception, our program, the main method was running, right? So it will help us if we want to handle runtime errors so that the program can continue to run or terminate gracefully, then this can be achieved using exceptions. Alright, so here we have the same examples which I tried in my demo. Since it is more systematic, so let's look at that. One of the example of exception is division by 0 or division involving 0. So here we have written a program which is using scanner class because we are prompting the user to input integers like so that we can perform the division. So you created an object input of the type scanner class using the way we use scanner class by saying new scanner system.in, and then you are prompting the user to input two integers. Right, we got the first integer here. Number 1 is our numerator and number 2 will be our denominator, and using this scanner object input we get the integers using input.nextInt and input.nextInt. And then in the last statement that we have, which is system.out.println, we are printing number 1, division number 2, and the result, right? So it will be something like this: 5 divided by 2 is 2. So that kind of output we are expecting if things are fine. If your denominator is not 0, then you get this kind of output. Now the problem will happen if you have divide by 0, right? So if your number 2 is a 0, then the output will be something like this. So if you input 1 and 0, then what you'll see this output, which will say that there is an exception in the main method, and the kind of exception is arithmetic exception. So you will pretty soon see that we have different categories of exceptions possible in our program. The exception that we have looked at till now is an example of arithmetic exception, because this involves division, and division is an arithmetic operation. Okay, so now how should we handle it properly? Now to handle it properly, we will have to make use of exceptions, and your program will change slightly. How will your program change? We will use try and catch block. So our try and catch block is right here. This is the complete try and catch block. Okay, and in the try block, if you look at, which starts from here and it continues to these two curly braces, will define the try block. In the try block, we will put the statement where we have the possibility of exception, and here division is the operation which may result in an exception. So we put that statement in the try block, and for every try block we should have a catch block as well. So we have written a catch block, and for catch, this catch is very similar to a method call, if you could recollect. Catch followed by parenthesis. Alright, and the parenthesis we have EX, which is an exception object. Alright, and then it is up to us what do we want to convey in the catch block. But catch block should give this information to the user that there has been an exception. Alright, so what we are doing, we are just printing out that exception. An integer cannot be divided by a 0. That's our message. Okay, and this program is better than the one we had in the slide, because here we did not have any exception. Here we have an exception. Alright, so this is more general. Here we have the capability of handling the exception. Great, let's move on. Now, the same point actually which I was trying to convey in my demo. For this simple looking program, we can handle exception using if-else statement. Right? If and else will work for the simple case where the division that you're doing is in the main method. But if your program is slightly more complicated, like the one where you have a method which is computing the division, then in that case you won't be able to solve that issue with just if-else statement. Okay, so now you have the example or the program that I kind of wrote towards the end, right? So the same point which I was saying that in this case is simpler. Why? Because the division that you're doing is in the main method itself. But if you take the division outside and you create another method like get quotient, then for that method you will have to use exception handling. So that's what we have in the slide. What if the runtime error occurs in a called method, right? So what is the called method? Here the name is different. It is quotient. If you have an exception in the quotient, then what will happen? So ideally what you should do whenever you suspect that a called method can have an exception, then you need to declare the called method appropriately. You should have this refined method header that conveys the information that this method can throw an exception, right? So we will have to rewrite the header of the quotient method as public static int because that's the quotient that you're returning. Okay, the return type is, the return statement says number 1 divided by number 2. Number 1 is right here, number 2 is right here. Okay, so you have public static int quotient, all the arguments that you usually have. These are formal arguments or formal parameters inside the parenthesis, which we will be needing in defining this quotient method, followed by the fact that it might throw an exception. So you'll say throws an exception, the type of exception. Okay, so when do we raise exception? If number 2 is equal to 0. That means if your denominator is going to be 0, what do? We create an exception. So exception has been created right here. New arithmetic exception. Alright, so you're using the constructor for creating arithmetic exception. So in my example, I used just exception, that is fine too. So first you create an exception object. So let me write this here. We created the arithmetic exception object by using new. Okay, by using the keyword new arithmetic exception, and then in the parenthesis writing a string, we created an arithmetic exception object. And using the keyword throw, what do? We pass on this exception back to the calling method. What throws does? It will pass the exception. We will discuss that in detail, don't worry about that, but since I have this in the program, I feel like I should explain that to you. The throw statement will pass the exception from calling method. Sorry, it's not calling method, it's from called method. Let me fix that. Called method, right? Called method, which in our case is this guy quotient, to the calling method. The calling method in our case is main method. Alright, so that's the purpose of throw. And in case there's no exception, then if number 2 is not 0, and then anyway if statement would be skipped and the division will take place as usual. Alright, so you define your quotient in a different way so that you can handle exception, and then back to the main program where this is similar, this is similar. The only thing that we have here is the incorporation of try and catch block in such a way that we can handle this exception. In the try block, if you pay attention to, then we have the call to quotient method, right? And if everything is fine, then the quotient method will return the proper value, which will be the result. And this thing will happen only when you're dividing by non-zero denominator and you get the correct output. Okay, so if there's no exception, the try block will work as the normal normal execution. These two statements will work. But in case there is an exception right here by divide by 0, then for the case when you have an exception, then this statement will be skipped. The exception right here will take you to the catch block. So divide by 0 will take you to the catch block. You will skip this statement which says system.out.println and the result thing. And the catch block will take care of this exception and will print out the message that you cannot divide by 0, it's an exception. And finally, the last statement that we have right here will be printed out. Very similar to the demo that I did. Now, what are the advantages of the exceptions? Because you might have realized that it's not as easy as if-else statement. You need some practice. Alright, and I will advise you to do this practice because this is an important concept. What exception does? It enables a method to throw an exception to its caller. Right, so what method we had here? We had, let me check that, quotient method. Quotient. So the quotient method that we had can throw the exception to the caller. And which method was caller? The caller was our main method. Okay, so that's the flexibility of exception handling. Without this capacity, I mean, if you don't have exception, then either the method must handle the exception or it should terminate the program. So which method we are referring to? We are referring to the method quotient. If the method quotient does not have this exception, this capability of throwing an exception, then this method should handle the exception itself. Okay, by writing its own try and catch in the body itself. Alright, or in the worst case, it will do something like exit kind of thing, which is not good. Okay, let's move on. Now there's another interesting situation which I believe I should do with a demo, and then I'll come back to this slide and I'll explain that to you. I will discard all those things that I did here, and let's look at another exception. Okay, input exception. So what do we do here? Let's declare a scanner, right? So for that thing, let me use scanner from here so that I'm not typing that again, and we can save some time. So I am using scanner class. I want the input from the user. I don't need two variables here because I will not do division. I'll say enter an integer input, or enter an integer. This is good. And then you have x. Right here you should say x is okay. So we are asking the user for some input integer, and let me do this thing also, stdin dot close. Perfect. A very simple program. I'm just asking the user to input some integer value. So integer 10, good. 10 is an integer, no issue at all. Everything worked fine. Now let's do something crazy and say 2.5. 2.5 is not an integer. So what should happen? An exception. Okay, so what kind of exception is that? Let's get that message from the compiler itself. Not compiler, I should say the Java, because this error is not a compile time error, so this is an exception which is being generated by Java or JVM. Input mismatch exception. What is input mismatch? Well, you declared x to be an integer, but when we are asking for integer value, you are passing on a double value, right? So input mismatch, that's an exception. So we should handle that. Now, how to handle this exception? Alright, so we will use the same try and catch block. So where can this exception happen? Exception is happening right here. Okay, where? It's happening on the line number 7, because when you're asking the user for an input, the user might give you inappropriate input. So if I have to write a try catch block, then let me write try and catch, and then I'll put the stuff in there. This is catch, and this is the line where I can have issues. Make sure that you understand which line, which statements I am putting in try block and why. Okay, now I will use this information which says input mismatch exception. So I should say input mismatch exception, because this exception is different, ex, and I'll have to import this one. Import input mismatch exception. Alright, I did not have that here, so I will import input mismatch exception. Alright, and what do we have here? I should take this guy in the try itself. Now let me write this catch statement here. So catch statement should be something like this: ex.message, get message. I'm not writing my own message. I will use the message that I'm getting from the exception which is being raised right here. Okay, good. So let's try it out. What I did, I took these two statements. The first statement, which is line number 9, is the one where I will have exception. This is where I had the exception, so I put that in the try block. And similarly, I took the other statement which is based on X also in the try block, otherwise it was complaining about it. And the catch, I have written a catch statement so that I can handle this exception. Cool, so let's run this program now. 5 and 6. Okay, oh sorry, I'm not doing division. 5 is a proper integer, so no issues at all. Let me input 2.5 now. Right, so null. Well, null I'm getting because probably there's no message in there. So what I should do here, let me write my own message, which I'll say incorrect input type. Please try again. Okay, so let's run this one. 2.999. Okay, so now you're getting the message which says that there was an exception and we handled the exception by writing try and catch. In the catch statement, I'm saying that it was incorrect. Please use proper input values. So this should give you some idea about another kind of exception which we call as input mismatch exception. Let me give one more interesting. Hello, this is string, right? It should not be we expecting an integer, but I gave a string input, so that was a problem. Now what I will do here, I will make this program as similar as possible to the demo that we have in the lecture slide. So let's make it a little complex and make it more flexible at the same time by letting the user try inputs until the input is what we want. Right, so what do I mean by this statement? Let's create a boolean continue input is equal to true. What does it mean? In all these cases, when I said hello, then it gave the message that incorrect input, but did not let me try again. So I'll make it more flexible by giving it the capability so that it can give the user further chance to input the proper value. So I will add one loop while continue input let's put everything here. All these things that we have goes in here. Okay, so since we have a while loop and I have a variable which will control the while loop. I am calling that continue input. So as long as the continue input is true, it will keep on looping and looping. Now if we were successful in getting the correct input from the user, so what you should do, you should say continue input is equal to false. Why? Because if I got the correct value of the input, which is an integer, then fine, I don't want to try that again. Only in case I have you know exception, I should ask the user to give to try again. Alright, so in case everything is fine, you will say continue input is equal to false, and that will take you out of this while loop. But in case the value was not correct, then it will take you to the catch block. Right here I should do something. What should I do here? Here I should ask the user to do this thing, right? Enter an integer again. Alright. Well, what I could do is, in place of this thing, I should pretty much say, let's run this. Okay, I believe we are good. There is one thing which I will fix after getting the compiler errors, sorry, the runtime error. So let's see. If I say 5, we are good. Okay, and if I say 1.5, right, so there is a bug. So how do we fix that bug? In order to fix that bug, which happens because of the way we input the input using keyboard and the way it accepts that, what we need to do here in the catch block is we will have to accept one input and discard that. In dot next not has next, it's just next. Alright, so if you do this, then it will fix this bug. You have to simply discard input. One input that we are getting from the keyboard is extra, because of which it is looping around, and it has to do with the enter key when we press. Okay, so if you have 6, which is an integer, we are good. If it is something else like 2 point this thing, then it's not an incorrect, this is not a correct value, so the program will prompt the user for one more time. And let me see hello for the next time. Hello is again not an integer, so it will keep on looping. It will give you multiple attempts to try the input. I'll say 5. Now you're good. Okay, so yeah, this is again an interesting problem which I'll highly encourage you to try out, and it gives you an example of an exception, and this exception is different from the first one. The first one that we had right here was an arithmetic exception, divide by 0 kind of a thing, and here this one that you see is an input mismatch exception. Alright, so back to the lecture slides. Okay, cool, right? So here we have it. Some difference, right? I wrote that program using while loop, whereas in the lecture slide you have do while. Okay, so you do need import statement. You are saying import java.util.star. Why star? Because here this star means you're importing two classes. Scanner is one which we'll need for this is scanner input, and there's another class which you need to import from java.util, and that one is input mismatch. Input mismatch exception. So that's the reason, rather than writing these two separate import statements, you can combine that by using java.util.star. Okay, so we want an input, and in the similar way as I did, we have a boolean variable called continue input, which we are setting as true, and then we are asking the user to try. and we are saying, okay, try asking the user for an integer input. If this thing works fine, if this is good, great, we will print that out, and we will set this condition which is resulting in the looping to false. We'll say continue input is equal to false, so that we can come out of it because everything went fine. But in case this is not the in case we had any problem, in case there was an exception raised here, then that will be caught by the catch statement. And the catch statement, we will prompt the user to loop again, come back to the try block, and try the luck next time. And here, the way I showed you, right, and this is a bug. There's a bug actually. The input is not properly captured, so we need to add an extra line like input.nextLine or input.next. Okay, and then the example is just the way we did it, exception in the demo. Again, now I hope you were already doing it as I was telling you in my lecture slides. Please try these examples yourself. Follow my videos, read the textbook, and you need to also type that. You need to also write that on a piece of paper and understand why are we writing a program in a certain way. Can you write that different way? And if you're writing it in a different way, is that working fine or not? If not, then where is the bug? How will you debug that? Okay, so programming is just like mathematics. You cannot learn mathematics by simply reading textbook or simply watching some videos. You have to solve problems yourself, and while doing that only you will realize whether you are learning it or not. And if you are making a mistake, then why are you making that mistake? You need practice. Alright, so now let's look at the different kind of exceptions. So we have different types for exceptions as well. Right here we have this inheritance hierarchy, and this object class should be familiar to you. That's the ultimate parent class in Java, and from that object class we have other derived classes. Now our discussion in this lecture is more about exception, so we will consider a part of the hierarchy. And from object class we have the next derived class called throwable, and in throwable we have two classes of the runtime errors, we can say the errors and the exceptions. So what do we have in error? So in error we have different subclasses of error class like linkage error, virtual machine error, and few other classes. Now these are some exceptions or runtime errors, we should say, or system errors which are thrown by Java virtual machine. And these kind of errors usually reflect some system level internal errors which user cannot handle. But the most that a user can do or a programmer can do about the system errors is just to notify that there have been some system errors, and these errors are more system related, more internal than the program that a programmer might write. That falls in the category of errors. Whereas the other class that we have is the exception class. So this exception and error classes that we have are derived from throwable class. Throwable class is the parent class, and from there we have the error subclass and the exception subclass. And we just looked at error subclass, which is being thrown by JVM and are mostly because of some internal system errors which user or the programmer cannot handle. The only thing that the programmer can do is to notify of this thing. Now exceptions class that you have here, these are the exceptions or the runtime errors which are caused by your program. That means which are caused by the programmer. Sorry about this, I will erase that. Okay. So we should be more concerned about exceptions because these are the errors or the runtime errors which are caused by the program or the programmer and some external circumstances, not like the internal errors as we have in errors. these errors can be caught and handled by our program. So we should be more concerned about exception class of uh, the throwable codes. Now here in exception also we have different categories. So initially we will look at the runtime exception kind of exceptions. Um, so what do we have in runtime exceptions? So in runtime exceptions also we have different categories like arithmetic exception we just saw, like divide by error and divide by zero. You have null pointer exception, we will look at that with some example. Index out of bound is something which you might have seen. So let me give you an example about index out of bound exception. So assume that my array has 4 elements in there. So 0, 1, 2, 3, these are the indices that I'll use to access the elements. Let me put some elements here, 3, 4, 0 and 9, and let's call it an A. This is int A. Now if I say A4, what does it mean? That means I want to access the element which is present at index number 4. Now look at this, this has the size 4. So the index values which are allowed are only 0, 1, 2 and 3. There's nothing like 4. Right? So this index is not allowed. Now we have an array of the size 4, so you cannot access the fifth element. So this corresponds to index out of bound exception. Similarly, we have illegal argument exception also. So what are these runtime exceptions? These are caused by programming errors such as bad casting, accessing an out of bound array, I just showed you this thing, or any numerical error, and this also includes divide by zeros. So we have we have already seen that, right? Okay, we haven't seen index out of bound, but we did see divide by zero error or exception, I should be saying. Now these exceptions that we have, they fall in two categories. One is called checked exception, the other one is called unchecked exception. So let's try to understand. So the runtime exception that we have seen, this is runtime exception, right? The highlighted section that you have here, this much, this is runtime exception, and then you have the error class. Now the runtime exception and the error and their subclasses are called unchecked exceptions, right? So unchecked exceptions means those exceptions which are not required to be handled always. So for these exceptions, it is up to you. If you want to handle those exceptions, great. If you don't handle these unchecked exceptions, you are fine too. Whereas for other kind of exceptions, like the exceptions like class not found exception, IO exceptions, and these three classes, these are called checked exceptions. For checked exceptions, we have to handle those. If we don't handle checked exceptions, then we will be in trouble. So here we have the IO exception that is required for file handling. So when I cover the lecture on file, then you will realize that you cannot write a program on file without handling the IO exception. You have to do it. You are bound to do it, right? So these kind of exceptions like class not found exception, IO exception, these are the example of checked exceptions. You have to handle these exceptions. Okay, so runtime exception, error, and their subclasses are known as unchecked exceptions, where all the other exceptions are known as checked exceptions, meaning that the compiler forces the programmer to check and deal with these exceptions, right? So if you don't do it, compiler will raise an alarm, will give you an error that you did not check these exceptions. So please take care of those exceptions. So when we work on files, you will see that happening. Okay, so these are unchecked exceptions which are highlighted, the error and runtime exceptions, and the remaining one were unchecked exceptions. So again, some more detail on unchecked exceptions. In most cases, unchecked exceptions reflect programming logical error that are not recoverable, so they should be handled. For example, Null pointer exception is thrown if you access an object through a reference variable before an object is assigned to it. Okay, so example like when can you have a null pointer exception? Index out of bound exception is thrown if you access an element in an array outside the bound of an array. Okay, so these are some logical errors that should be corrected by the programmer. Alright, and unchecked exceptions can occur anywhere in your program. And why are these unchecked? Because if you keep on adding exceptions for every situation, then your program might become cumbersome. So just to give you the flexibility that you could write a program without even bothering about the exceptions, these are unchecked exceptions. So to avoid cumbersome overuse of try and catch blocks, Java does not mandate, right? For unchecked, Java does not mandate. So this is important thing you should keep in mind. Java does not mandate you to write the code to catch unchecked exceptions, right? So that is an interesting difference between unchecked and checked. Java does not mandate you to write code to catch unchecked exceptions, whereas for checked exception you will have to Java will enforce you, or the compiler will enforce you to um, write the exception for that. So I will stop right here, and I will continue in my next video lecture, and I'll cover more examples on exceptions. Bye bye.